Now we will draw the moment and shear for this beam. This beam is subjected to two types of load, distributed load and point load, and it is supported at point A and point B. To draw the shear and moment diagram, we need to determine the reaction at point A and point B. To determine the reaction at point B, we will sum the moment at A, and the moment sum at point A will be equal to 10 times 6 minus 0.8 times 24 times 12, and this is a distributed load. It is 0.8 kb per feet per length, so we will multiply the load intensity by the length, then we will and then it will be the center of this load will be in the middle because it is rectangle and it is uniform. It is uniform load, and we will multiply it by 12, so it will give us the moment at point A. Then we have minus 8 times 30, the last point load, plus vertical load times 24 equals 0, and we will get the reaction at point B equals 17.1 kb. Now to determine the reaction at point A, we will simply sum the force in the vertical direction, and it will be minus 10 minus 0.8 times 24 minus 8 plus 17.1 plus the reaction at point A, and it will be equal to 20.1. Now we have the reaction at point A and at point B. We can simply draw the shear and moment diagram. Here we have our beam. At the edge of the beam, the shear will go by minus 10 because the point load is downward, so minus 10. Then it will go straight because we don't have any load between point A and the edge of the beam. Then it will go up by 20.1. 20.1 is the reaction at point A, so it will be minus 10 plus 20.1, and it will be equal to 10.1 kb. Then we have between point A and B distributed load, uniformly distributed load, so the shear diagram in this area will be linear, and it will be 10.1 minus 0.8 times 24, and it will be minus 9.10 kb. At point B, we have our reaction equals 17.1, so the shear at this point will be minus 9.10 plus 17.1, and it will be equal to 8 kb. From point B to the edge of the beam, we don't have any load, so it will go straight. Then it will go down by 8 kb, which is our load because it is downward, and it will be 0, 0 at this point. Now to draw the moment diagram, we need to determine the area in shear diagram. First area will be minus 10 times 6, and it will be minus 60. Then we have this triangle. Now to determine the area for the triangle, we need to find this distance. To find this distance, we can easily determine it from this equation. This distance is equal to 24 divided by 10.10 plus 9.1 times 10.10, and we will get 12.625 feet, and the second distance will be equal to 24 minus 12.625 feet, and this will be equal to 11.375. Now we will determine the area for the first triangle, and it will be 0.5 times 12.625 times 10.10, and we will add this one to minus 60, and we will get 3.75. Then we will determine the area of the second triangle, and it will be equal to 0.5 times 9.1 times 11.375, and we will subtract this one from 3.75, and we will get minus 48. Then we will add to the minus 48 8 times 6. It will be minus 48 plus 48, and it will be 0, 0.